The next one we have is the even number sequence. So kids, as we can see here, this is a sequence of even numbers. So what are even numbers? The numbers which are divisible by 2. They are called as even numbers. And in this sequence, in this pattern, what we can see is that the sequence starts with 2. The first number of this sequence is 2, and then we get the next number by adding 2 to the previous number, right? So if I am adding 2 to this 2, I'll get 4. If I'll add 2 to this 4, I will get 6, the next number, and so on. Now let us find out the terms at the different positions in this sequence. So at the first position A1 we have 2, at the second position A2 we have 4, third position A3 we have 6, fourth position A4 we have 8, fifth position we have 10, sixth position we have 12, and seventh position we have 14. So in this sequence, these are the terms at the various positions. Now let us try to find out the pattern which this sequence is following. So as we have seen that the first number of this sequence is 2. So I am writing the same here. The first number of the sequence is 2, right? And the next number, and we get the next number, by adding 2, right? By adding 2 to the previous number. So we have seen here that the first number was 2, and when we added 2 to this, we get the next number, which is 4. So I can write here that A1 is 2, that is the first number, and I am deriving A2 by adding 2 to A1. I am adding 2 to the previous number, which was A1. So A2 becomes 4. Similarly, if I have to take out A3, I will add A to the previous number of A3, which was A2. So I will add 2 to the previous number, A2. So that is 2 plus 4, because A2 was 4, and we will get A3 as 6. So similarly, we can find out these all numbers, that at which position which number is present here. Okay. So now if I have to derive the nth term here, so what is the formula? The formula to derive nth term of in the even number sequence is 2n. Okay. So if I have to derive the nth term in the even number sequence, I have this formula. Nth term is equal to 2n. Let's see how it works. Okay. So I'm taking example. Let's say I have to take out 17th term of this sequence. I need n17. That which number or which term is present at the 17th position of this sequence. So what we will do? We will multiply 2 with n. N is 17 here. So we will get 34. That means in this even number sequence, the number or the term which is present at the 17th position is 34. Similarly, we can do this for any nth number. Let us try to find out the term which is present at, let's say now I am taking this as 31. Okay. So the nth term, that is the 31st term will be 2n, 2 times 31, which makes it 62. So this is how we can derive any term in the even number sequence. Okay, kids? Now let us move to the next series. So the next series which is given here, this is called as triangular number series. Okay, so let us try to find out that how this series is formed first. So here we can see the first number is 1. So at first position we have 1. At second position, I'm writing here. At second position we have 3. At third position we have 6. Fourth position we have 10. Fifth is 15. Sixth is 21. 7 is 28 and so on. So if you see it closely, how we are getting the next number is, the first number is 1. That is done. So I'm writing here the A1 is 1. Right? Now, how we have derived A2 here is, we are adding the previous number to the position of the next number. Okay? That means I am adding 1 to the position here, which was 2. The position of the next number is 2. This is second position. This is A2. Right? So I'm adding this 1 to this 2 and I'm getting this number 3. So at second position, this 3 is present. We get 3 by this method. Now this is the third position, A3. If I have to find out the value, what I'll do is, I will add the previous number, which was 3, to the position of the current number, which is again 3. So this 3 plus this 3. This 3 plus this position 3, we will get 6. So that's how we are getting 6 here. Similarly, A4. To find out A4, the number here, I will take the previous number 6 and I will add the current number's position. This position, this is fourth position. See, this was first position, second position, A1, A2, A3, A4 we have done the terms. So one is, this is first position, this is second, third, fourth, fifth, sixth and so on, right? So A4, to find out the number or the term at A4, we will add the previous number to the current position. Means I will add 6 to this 4 and we get 10 here. So kids, I am marking these number in quotes here so that you can easily identify that these are the positions. We are adding the previous numbers to the positions to get the next number. So likewise, A5. A5, we will take the previous number, which was 10, and the fifth position. Fifth position, that is 5. Something I am marking like this. This is 15. Right? Next, A6. A6, again, I will add 15 to the sixth position. 6 is here. So 15 plus 6 is 21. So that's how we will get the numbers here. So what I can write here is, what is the pattern it is following is, the pattern is the first number is 1, first number is 1 and next number is the addition of previous number and the position of the number which we have to find out of current number. I'm writing here the number which we are writing. Okay, So this is how it will work. Now, coming here, what we have is, if I have to derive any number, any nth number, so kids, if we can see here, when we are deriving 3, so this is what? This is 1 plus 2. When I'm deriving 6, this is what? This is 3 plus the next number. So basically here, the any number, it is sum of the previous numbers, the sum of the previous and natural numbers. So we have the formula for this. The formula is, to derive the nth term, we have the sum, it is the sum of the first n natural numbers. So that is n multiplied by n plus 1 divided by 2. Using this formula, we can easily derive any term in this triangular series. This is called a triangular numbers or the triangular number series. If we have to derive any term at any position, we have to use this formula, that is sum of the n natural number. So let us take one example. I'm taking one example here. If I have to derive the number which is present here, let's say I want the number at 10th position. Okay, so I need a10, that what term would be there at 10th position. So we have n is equal to 10. So I will write 10 multiply by 10 plus 1 by 2, which is, we can cancel, right? This is 55. So in this series, at 10th place, at the 10th position, we will have the number 55. So likewise, we can use this formula to derive any term. Okay. Next we have squares. So what is squares? First of all, so when we say we have to find a square of a number, square of a number is, we have to multiply that number with itself once. Okay, if I want the square of the number 2, so it will be 2 multiplied by 2, and we denote it by this, the square of 2. That means 2 times 2. This is called the square of the number. So this is what we mean by squares. Similarly, we can find out the square of any term. If I say, what is the square of 5? It will be this. 5 multiplied by 5. That is 25. And here it was 4. The square of 5 is 25. The square of 2 is 4. Okay. Now, coming back to the sequence, let us see. The number which is present at the first position is 1. The number at the second position is 4. Third position, we have 9. Fourth position, we have 16. Fifth position, 25, and so on. Okay. So if we see these numbers closely, we can see easily that this first number is 1. It can be taken as a square of 1. Okay. You can say A1 is 1, the square of 1. Similarly, at second position, it is 4. This is the square of 2. That is 2 multiplied by 2. That's how we get 4 here. This is a square sequence. Then at third position, we have 9. So 9 is what? It is square of 3. That is 3 multiplied by 3 is 9. Okay. So that's how we are getting this sequence here. Similarly, 16 is square of 4. 4 multiplied by 4 is 16. And this 25 is square of 5. 5 multiplied by 5 is 25. Similarly, 6 multiplied by 6 is 36 at 6th place. 7 multiplied by 7 is 49 at 7th place. So this is a series of square numbers, right? So, and if you observe this series, you will come to know that at every position, the term which is present, it is the square of that position itself. At first position, it is square of 1. At second position, it is square of 2. Third position, square of 3. Similarly, in fourth position, it was 16, which is again square of 4. 25 is square of 5, which is at fifth position. Sixth position, we have 36, which is square of 6, and so on. So, here, what is the pattern? The pattern is, it is a series of, you can write here, the term is square of the position on which it is present. Okay? On which it is present. Now, so we can easily determine that what is the nth term in this series. Nth term will be, what will be nth term? Nth term means the term at position n. It will be n square, because first position was 1 square, second was 2 square, 3 is 3 square, fourth is 4 square, and so on. So similarly, if we have to find out the nth term, we will do the square of that particular position. Now, example I am taking here is, let us find the 11th term of this series. If we have to find the 11th term, it will be the square of 11, which is 11 multiplied by 11, that is equal to 121. This is the 11th term of the series. Similarly, we can find out the term at any position by using this formula. Okay, I am highlighting the formula also. Okay, and so kids, this whole content, it is the, I have taken the content from both R.S. Aggarwal and the NCERT book. It's a combined content. Yeah, it's smart. Now, coming to cubes. So, like how we had squares, we have done squares now, we have cubes also. What is a cube? A cube is the, we have to multiply the same number thrice. And how we represent it? We represent it as, I'll tell you. So cube of a number is, let's say number, let's say I'm denoting this number by A, or let's say I'll denote it by Y. I just don't want to confuse your A and N with this. So I am taking the number as Y. So cube of a number will be Y multiplied by Y multiplied by Y 3 times, and we denote it as Y cube. Cube means 3. In numerics, we write cube as 3 and we write square as 2. So if I say how to write a cube of a number, how will you write the cube of 4? It will be like this. It will be represented something like this, and answer will be 4 multiplied by 4 multiplied by 4, which is 64. This is example of a cube. Now, coming to this sequence, this one. So let us find out the terms. At first position, we have 1. Second position, we have 8. Okay. So can I write this 8 as 2 multiplied by 2 multiplied by 2? That is, it is the cube of 2. Okay. 2 cube is 8. Next, at third position, we have this 9. I think there is some, yeah, I'm sorry kids, because 9 should not come here. Let me correct it. It should be 27. Okay, yeah, now it's correct. So here it is 27. 27 is what? It is cube of 3. 3 multiplied by 3 multiplied by 3 is 27. So at third position we have cube of 3. Similarly, fourth position we have 64, which we just find out. So we can write at A4, fourth position we have 4 cube. Similarly, at A5, the fifth position, we have 5 multiplied by 5 multiplied by 5, that is 5 cube. So we can easily see that in this whole series, at every position, the term which is present at the position, it is the cube of the position itself. First position, cube of 1. Second position, we have cube of 2. Then cube of 3, cube of 4, and so on. So we can now easily identify the pattern. Okay. And the pattern here is the term at a position, the term at a position is a cube of the position itself, right? Because the term at 1 is the cube of 1. 1 cube is 1. The term at second position, it is the cube of 2. 3 is a cube of 3, 4 is a cube of 4, 5 is a cube of 5. So that means the term at the nth position will be cube of, it will be cube of n. Okay? Because we have seen the term at any position is a cube of that term itself. So again, I am highlighting it and we are going to take one example. Let us try to find out that what is present at 7th term. 7th position, sorry. The term at the 7th position. Yeah. So this will be 7 cube, which is 7 multiplied by 7 multiplied by 7, and this come out as 343. Okay. Yeah. So kids, now we are left with 3 more sequences. They are powers of 2, powers of 3, and Viranka numbers, which we also call as Fibonacci series. These 3 sequences I'm going to take in the next class. Otherwise, you will get confused. But till that time, I want you all to go through this content. Try to practice, try to take more examples on your own of each and every sequences. And if at any place you feel any query, you get confused, just email me on my email ID. I will look into your queries and resolve it in a video or in a mail. Okay, kids? So thanks for attending this class and I will see you in the next class.